From deep inside the Death Star, I'm Chad Beater.
And I'm Andrew Richards.
And welcome to Defrag Tools, the show that takes you inside Microsoft and inside Windows. Andrew is back this week.
Out of the trenches.
It's been a little while. We've been pretty busy with, Windows, what are we calling it? Spring Creators Update, right?
Yep, that's the one.
Redstone 4 is the code name, but it's winding down now. We're getting it out the door, and we're here. We're doing this.
Yep.
And we're going to talk about H results.
Yeah, this kind of popped in my head as, obviously when we wind down Windows and help people fix their issues, you're looking at the error code and the error number. And a lot of the error numbers actually have like description to them. And actually if they're of type H result, which is just a normal error code, it's just a classification of error codes, I suppose you could call it. They actually have these descriptions in them. So we thought we might deep dive into what an H result is. This is the codes you're seeing on,
all over.
Everywhere. Whenever something fails, you say, hey, error code blah popped up on the screen.
Yeah. C00001 or whatever it is.
More A007002 or all these other
Right,
ones.
yeah, all these codes. I'm like, what do they mean?
And then, we both are like this in a situation where we can just stare at the screen and go, well, that's a file not found. And you go, how the hell did you get from this esoteric bunch of hexadecimal numbers to that observation so quickly? And what we're going to do is hopefully teach you what the tricks are and how you can actually quickly learn it. And actually there's only about 5 or 10 numbers you actually need to remember, as in the common ones.
The common ones.
And that kind of gets you a long way. So like file not found, access denied, general failure, I don't know what's happening type stuff.
It turns out there is a logic to this, unbelievably, or believably. The various bit fields mean things, right?
They do. And so here's some very common names and some very common codes, and I'll zoom up a bit. These 8s on the front are very common, and they're very common because that's part of the rule, and we'll go into that very soon. Mm-hmm. But although some of these are very obvious, things like access denied when you don't have access to some object like a file or something. Mm-hmm. General failures. Whoops, something went wrong. Right. This one at the bottom is quite common. It's like the default error code you use when you don't know what error code or what happened really.
Right.
And so you will see this bottom one. Sometimes you'll see it called catastrophic failure. The CLR actually maps it to the error message catastrophic failure, and in Windows we map it to unexpected failure.
And they could have gone with something a little more like apocalyptic failure. I don't know. Catastrophic just doesn't quite seem bad enough.
Pretty bad anyway. While we're here, I'm going to point out that you'll notice that in the middle here sometimes there's zeros, sometimes there's 7s. And actually there can be any number in the middle, but we'll point out the 0 and the 7. Just keep that in your mind.
Okay.
So what is an H result? So an H result is a D word. It means it's 4 bytes of data.
Right.
And you represent that with 8 letters of hex. So each 4 bits is a letter in the alphabet from 0 to F.
A letter or a number, sure.
A letter or a number, sorry. A digit. A character.
A hexadecimal.
Whatever. 0 to F.
Hex digit, yeah.
And so you're going to see 8 up to 8 letters, or you will see 8 letters. It is very common, it's a kind of standard that when you're printing out an H result on the screen, you 0 pad it. So if the error code is 12, then it would put 0000012. Right. Just because you want to keep that 8 character annotation on it. It's also very common to always print it out in hexadecimal rather than decimal. If you see -214 something, it's an H result. That's how an upper bit of 80 something runs out in decimal. So if you see -214 something, it's an H result.
You'll see those sometimes. You have to go convert them to hex, and then you'll be like, oh, it's C000.
Something very simple. Some rounded nice number. Mm-hmm. So the way it works is you pack in at the bottom 16 bits, which was for a long time, Windows 16-bit, everything was defined as 16 bits. That's the code. That's the thought process of what went wrong. Right?
Okay.
Then above that, we then have the tricks and the tips. The next one is the facility, and it's actually only 15 bits, not 16 bits. Is it 15? Oh, whatever it is. It's
like 10
it's 11 bits. 11 bits. It doesn't actually round off to a perfect like FFF or something. It's actually missing 1 bit. Tends to not matter because facilities only go up to in the hundreds right now. They're not using all nowhere close to that many bits.
Right.
So it is kind of irrelevant. The next bit 27X, is actually not used by anybody. So
Okay.
basically you can kind of cheat and assume it's part of the facility and it's just a 0.
Okay.
So that kind of gives you the rounding back to a couple of letters. So normally what you do is you say the bottom 4, so those FFFFs are the code. The next 2 are the facility. It's not technically true, but it's good enough in
Close
practice.
enough in practice.
And then the top bits define something that isn't used, and then the last, the 28 and 29 aren't used. They're always 0, or very commonly 0. Technically 29, which is the client bit, the customer bit. If you want to define your own code, that's how you would do it. I have never seen someone do it in my life.
Never seen
So
anyone.
they put it in the protocol or in the standard, and I've never seen anybody actually do
Everyone
it.
just uses the Microsoft ones.
Yeah. And then the last 2 are actually where the gold is. And so 30 and 31. So as much as it's called restricted or reserved, you can think of 30 as being a warning. Right?
Okay.
And so in the bit fields, that represents a character of 4. And then the top one, bit 31, is error. So it's kind of like error and warning.
Okay.
And so the top one, being the last bit, represents an 8. Lo and behold, we get a lot of 8s at the front.
80000 something, right?
Right.
Which means error, but the second bit would be 0, so the error but not severe.
Yes, exactly right.
Okay.
So if you turn both of them on,
Yeah.
and turn error on and warning on,
Right.
you end up with 8 plus 4, so 8, 9, A, B, C.
C.
And the other thing you very regularly see is a C 00 something something something.
Which just basically, so a C000005 would be error, warning, error code 5,
Which is access denied.
which is access denied. That's how
Right.
we get it. Okay.
And so we kind of cheat by saying, well, if you've got error and warning turned on, that's super bad. It happens to make the letter C, and we say it's a critical. Right? So we really have
a little mental
warning,
shortcut.
warning, error, and critical.
Okay.
If you see a C, the odds are it's very very hard to recover from. And a lot of error codes that fly around in WinRT are C-based, as in they have both turned on. But in more of the Win32 land, the last 20 years, it's all been mainly 8. That warning bit is rarely turned on.
Okay.
And so the way that H result works is from a purity point of view is if the top bit is turned on, the 8-bit is turned on, it is an error and we are on the bad path.
Right.
If the bit is turned off, and that includes warning being turned on, if the other 31 bits are there solely, then it's success. And so you can actually have a successful warning.
So that'd be like a 4 would be the first.
Would be
hex
success.
digit.
It could be successful, yes.
Okay.
And only 8, the 8-bit turned on, would be a failure. And there's macros for this. So the way that you'd process in code this concept is you use the succeeded macro, and all it's doing is seeing if it's greater than or equal to 0. And you go, well, that's a bit weird. Doesn't the 8 mean that we're greater than 0? No, because it's a signed number. So the bottom bit, or that last bit being turned on,
Bit 31.
moves you into the negative. And so with 8 turned on, it's actually a negative number. Hence, when you print it as decimal,
Right.
it's negative 214, blah, 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 rather than positive 214. And that's actually quite important. So when you're copy pasting it and trying to convert it from decimal to hex, it's important to include the negative sign.
The negative sign.
Otherwise, the math is off.
Right, otherwise you'll get a success code instead of a failure code. So then if it's negative, that means the first bit is set, which is just sort of how binary math works in computers, right? Signed integers.
Yeah.
Okay,
And
that's,
so-
that's very handy. I
And
did
then
not know that.
the opposite's true. So if it's 0 or greater, 0 is SOK macro. It is SOK is 0. Everything's okay. Success.
Right.
Success. Okay. Error.
Okay.
And then technically, if you were making a macro that represents a C1, you would have C underscore on the front and W underscore on the front for warning, right?
Oh, right, okay.
So succeeded says, hey, if it's greater than 0, we're good. And then failed is the opposite of that. It says if it's less than 0.
And you see these all over the Windows code where people have used those macros to see if a result was good or bad.
Correct. There is one error code that's not listed here, which is S underscore false, and we should get this page updated. S underscore false is 00001. The idea behind SOK and S false is they're both successful, but one returned a value and one didn't. So for example, you might go, you have a car object and you say, give me the driver. Right?
Oh, right.
Now, most of the time, the driver object or the person object, the person's driving the car, and you return a person object. So you would return the object and set the error code to SOK.
Right.
But if the car is parked and there is no driver right now, it's completely valid to ask that question. But what you do is you return a null person object, and to give a hint to the caller that everything went okay,
right.
the car's not on fire or anything, but we did not return you data, you returned S_false.
Right.
And that's the convention. That's very important if you're writing C++ code that talks to CLR, to .NET.
Okay.
It expects that intrinsic. If you return like E_fail or E_invalid_arg or whatever else you want to do, it will everything that's not a success will throw an exception. So if you have a property on an object on the car and you just want to go P equals car.person, and then the very next line of code you want to say if P doesn't equal null, go use them, you have to return a success.
Right. Okay.
If you return an error, you're just going to see
It's going to throw an exception, then you got to handle it, or if it doesn't get handled, it's going to bad things.
And this makes your code ugly, quite frankly.
Yeah.
And so that's a very important distinction. So the important thing to note there is S_false is the value of 1, which is succeeded. And so it's a common mistake that you see someone run one of these functions, they put an if succeeded macro around it, it returns a null object and then it crashes, access violates on the null object. And it's because sometimes you need to look at the contract and most APIs will say this, I return SOK on success, I return S_false when there's a null object coming out, and I throw E_something on something that went wrong.
Errors, yeah.
And so the if statement needs to be, instead of going if succeeded, if blah, blah, blah equals S_false. So that gets you the true-false nature of error codes.
Right.
All right, so the next phase is where did the error code come from? And this is where those 7s I was talking about and stuff.
Those upper bits there, not upper, but middle bits.
Yeah, and this facility range, right, which is I just go whatever, it's these 2 bits.
Right.
It's these 2 bits. The facility basically is the ability to have the same error code manufactured by different APIs. So for example, for the Win32 facility, which is facility 7, error code 5 is access denied.
We know, our old friend, yeah.
Let's assume that this 4 wasn't there. We could say that for the null facility, or say this was number 1A, or whatever you want to call it, 5 could represent no person in car.
Something else, totally.
Right, or whatever it is, right? Or database offline,
Right.
or something completely different. So it allows 2 different APIs to share the same code.
Right.
And that's exactly why Edge results were invented, to move these 16-bit codes up into a broader ecosystem where they could be shared. All right?
Okay.
So the facility basically is the middle. And the way that particularly you see people do this, and why that 7 in the middle is so popular, is we ship a macro called hresult from Win32 code. So you pass in like that 5 for access denied,
Right.
put it into here, it will pack the right bits, it'll put the 5 at the bottom, it'll put 7 in the middle, and it will set the error at the top. That's the only macro we ship, and so most people tend to use it, right? But there is lots and lots of facilities. If you open up winerror.h, which you need to get via the SDK, it's not shipped with Visual Studio, you have to install the platform SDK, all the facilities are listed.
Right.
And the numbers max out at 1,000 or 2,000. So it's not that high in the, it's not that close to 64K.
Not a ton of them. There's some that you see used, like I noticed, like RPC, you see those sometimes.
Yeah, and so the big one in here, and I'll just have to find it because there's so many, is Win32,
7.
which is number 7.
Right.
The other one that you will see, and then here's the null facility, which is the one where you get zeros. The null facilities are defined as agnostic, as in software agnostic or platform agnostic. It's just, this is eFail.
Right.
It doesn't have any association with some technology or anything. It's just common code. And that's what this page is listing. This page is listing a lot of the common codes like eFail and eAbort and stuff like that.
That's right. So that's right, which is why those bits there are 0 in so many of these. Right.
And so there's lots in here. One of the ones that you will see a lot is I'm going to look for URT, and you go, why am I looking? Whoops. You go, well, why am I pointing out URT?
Right.
What's URT stand for?
Yeah, I don't know. Uniform something.
Universal Runtime was the original name for the CLR.
Oh.
This is .NET.
.NET.
Which actually is 1.3 in hex. It's not 19s. It's going to be hex. Unfortunately, this is not defined in hexadecimal to make it easier to read.
Yeah, you gotta do the math.
Yeah, you got to do the math. But URT is the one you'll see a lot, which is the CLR. 13.
So any kind of .NET code or managed code is going to use that one a lot.
So if you're a C programmer and you're delving through header files and stuff, you need to actually look for URT, not look for CLR. The other one you see is COR for core. And then there's lots in here. There's ones in here for most systems. The one I will look for, I think it's in here. HTTP. So here's an example of how, let's say you got a 404 from a website.
Right.
This would be the appropriate way to pack a 404. You would put 404 as the code, and then you would transport it saying this was an HTTP transport issue, for example.
I see.
Right.
Okay.
And there's lots in here, and they all have their own. Obviously, every one of these has its own code range, right? You can't really share them, right? So this macro for the Win32 one is very common, and it's common because that's what you get back from the OS.
Right.
So if you see a 7, right? It's Win32. That's one of the very few things you need to remember. And then you'll find that certain numbers you'll start remembering. Like 5 is access denied.
Yeah.
2 is file not found. 3 is path not found.
Right.
There's certain numbers that you just start remembering. And how do I know these and how do you look them up? The phrase you need to remember is system error codes. And I'll do this search again. Actually, I'm going to copy paste it because I'm lazy. If you search for system error codes, this is the landing page for the Win32 codes. Unfortunately, if you search for Win32 codes, you don't get them. But system error codes, I actually have this page pinned to my desktop.
You use this so often.
I do, because when I'm making code, I go through here and go, what's an appropriate error code to raise to truly represent this situation?
Right.
The bottom 0 to 499 range, or 0 to 1F3 range in hex tends to be where most of the gold is.
Yeah.
This is where you're getting file not found.
Common one.
Path not found. Too many files open is pretty rare. Access denied. Invalid handles up there. You'll see that every once in a while. Yeah. And then what I tend to do is when I'm writing code is I'll search for words on this page that kind of have the right feeling, like invalid parameter. So I might go, what's the invalid parameter? There you go. It's 57. And I'm going to take a guess here. I would not be surprised if invalid parameter is what that is.
Look at that.
Pure guess.
Yeah.
So I didn't even know that, and that was my guess. So there is lots of codes here. The bottom here, I'm going to point this out because I have noticed this is a common mistake. All of these are straight error codes. This bottom one actually is the error codes for HTTP transport, right? So this is the 12,000 range. Particularly, I know I'm kind of used to this range. This range here, internet error codes.
These are your.
This is when you talk into websites, right? And particularly, things like timing out and all these HTTP errors. Mm-hmm. The reason I mention this error code range is I see a lot of people mapping these codes to the Win32 facility. But technically it should be in the Win HTTP facility. And so sometimes in your code, you may have to go, if it's this code in the Win32 facility or this code in the Win HTTP facility, then do my code. You have to code it both ways because this particular range should be associated with the HTTP facility, but people make that mistake. So in my code, I know because I write the symbol protocol, I code it both ways for that mistake.
Right.
But yeah, so error codes are one of those things where just by dissecting the first bit, is going to give you if it's an error. The middle is going to tell you what subsystem and Windows made it, and then the magic on the end will give you the error code.
And go look at those websites to go correlate what they are. And if you're in the debugger, in WinDBG, you can do bang error, right?
I should actually point that out. So the debugger does come with, so I'm just debugging Notepad, it's running, everything's going great. And then, I can do this guy, it has success. But so let's say that there's bang error in the debugger, which is built into the debugger, and let's choose C0070012, right?
Sure.
And there are no more files. The PDE extension, which we've talked about in the past, will actually go, it's very H-result centric, so it will work out what facility it's from. It gives you the nice name, and then it will give you the message that represents it. If I change that into a CLR one, it'll tell me, is there any of these got a nice...
You got to find one that actually
has
exists.
a description, but yeah. So, we should actually just try better. So it will give you the facility it's from and also the more common name. So like it knows that URT is actually .NET CLR, for example. If we choose a much higher number, I don't know what we should try, D. Yeah, it's
unknown instead of URT.
The user mode common log facility, whatever that is.
Right. Not one that I've ever encountered.
But yeah, the PD extension it's aware of all the facilities, and actually for the ones which it has deep knowledge of, it knows how to resolve the messages and all that type of stuff. So yes, that's H-results.
Very cool.
From a coding point of view, if you can accurately put out H-results, you are in a much better support experience. Don't be so wishy-washy and just use 2 or 3. The more granular you are, it easier it is to find where the fault came from.
Yeah.
Being deliberate in the way that you code things. Don't just return e-file because it's easy, it's the one you can remember.
Yeah.
If someone gave you a bad parameter, return invalid arg.
Yeah.
If you haven't got around to writing the code yet, write e_not implemented.
Right.
The H-result that you return when you're doing particularly between C++ and CLR, that defines the CLR exception that gets created and thrown. If you return e_not implemented, it will return a system.not implemented exception. If you return e_invalid arg, it's going to make a system.invalid argument exception. So give people the chance to understand what's wrong and adapt to it.
Those of us who spend our lives debugging other people's code very much appreciate when people use descriptive error codes.
Yes.
And accurate error codes.
So hopefully that's a little deep dive that can help you debug things. I watch things on PC and on TV and stuff, and the error code you see, you go, oh, I know what the error code is. And you can be that person with your friends and geek out.
Yeah, I always get people when they show a blue screen on TV, and I'm like, oh yeah, that's a kernel mode exception not handled.
I think particularly with the ones like C002 with file not found, path not found, access denied, it's a very quick way to go, I know what we should do next, we should jump into process monitor because it's file-based. But if you see a facilities that's more like, something obscure, like some cryptography thing or something, you go, yeah, I probably can't really root cause this one quickly. So it kind of gives you a very quick ballpark on your success rate. So
cool.
Anyway, hopefully that's useful.
Yeah, very cool. I mean, I've spent my life seeing those, and I learned some stuff. It's interesting to see how they all fit together and where they're defined.
It's quite algorithmic, actually. Yeah. It's actually quite elegant, actually.
Yeah, it's pretty good. It's pretty good. And
good old 1990s tech.
That's right. And now you know. So. All right. Well, that's our show. Thanks for watching. As always, if you have questions or comments, put them in the show notes down below. Or email us at dfragtools@microsoft.com. And thanks for watching.
See you next week.